Good morning. Thank you for joining us. My name is Russ Henry, and on behalf of Cumulus Networks, I'd like to welcome you to the Network Interface Manager IF Updown 2 webinar. Our presenter today is Rupa Prabhu. She is a member of the technical staff at Cumulus Networks. At Cumulus, she works on networking in the Linux kernel and user space, network interface management, and others. The webinar will be about 30 to 45 minutes, and we will have a short demo near the end of the presentation. We will answer questions from the participants at the end if time permits. For those of you interested, you have the opportunity to ask questions during the webinar by using the window marked Questions. Simply type in your question and click Send. You can also tweet your questions to us. Our Twitter handle is @CumulusNetworks. With that, I'd like to turn this over to Rupa.
Hello, everyone. My name is Rupa. Thank you, Russ, for the introduction. Today, I'm the author of IF Updown 2, and today I plan to talk a little bit about Linux Network Interface Management, Linux Network Interface Managers, a bit about Debian's IF Updown, and why we did IF Updown 2, and talk about some of the features of IF Updown 2. So, network interface configuration on Linux. The Linux kernel provides APIs for user space to configure network interfaces. And these APIs have evolved over time. It was ioctls before, and then sysctls and netlink. All these three APIs actually coexist today, and you'll find different tools using many of these APIs. And there are certain native network configuration tools that come with every Linux distribution. And these examples for these are IPRoute2, sysctl, eth2, brctl. And why do I call them native is because most of these tools are actually maintained by the people who add the APIs in the kernel. So they are these are maintained by those people, and so any feature that goes into the kernel in these areas are likely to get into these tools way faster than any other user space tools. And these are actually released on the kernel mailing list as well. And due to that, they become part of every distribution by default. What is a Linux Network Interface Manager? A Network Interface Manager is usually a higher level tool which unifies network interface configuration on a system, on a Linux distribution. And this is a tool that may vary between Linux distributions. And the reason for that is most of these unified network interface managers are optimized for a particular distribution use case. And this is a bigger world picture of Linux Network Interface Manager tools. The slide looks a bit busy, but here you can see there are network interface managers from various distributions like the Debian IF Updown, Red Hat's Network Manager, OpenWRT's NetIFT. OpenWRT, if people don't know, is a Linux distribution for wireless routers. And you'll see native tools like IPRoute2, bridgeutils, and these tools, they can talk to kernel using different APIs. So sometimes it's netlink, and sometimes it's sysfs, ioctl, sysctls, and so on. And netlink is the current newest API. Most of the network interface configuration is moving to the netlink API. And in the center of the slide, you'll see a stack of network interfaces. This is to show that network interfaces in Linux are stacked, and there is an inherent dependency between network interfaces. So you have to bring interfaces up in a certain order. For example, on the left, you see a bridge, and you have ports, which are nothing but interfaces, VLAN interfaces, which are on the physical ports. And SWP star interfaces here in this picture are nothing but the switch ports in the Cumulus Linux context. But on your server, they could be ETH0, ETH1, your NIC ports, and so on. So to give a little bit of context about the specific network interface configuration on network switches, I wanted to bring up this slide on what are the characteristics of network interface configuration on network switches. And that will lead to why we had to add some features to IF Up-Down to support our use case on network switches. So if on a server, you usually have NIC ports. If it's SRIOV, you have about a few 64 port NIC and so on. When you come to a switch, now you have a 48 gig port switch, and if these are 40 gig ports, you can actually break them out, and the number of ports, physical ports, can go beyond 100. And then, since it's Linux, to create VLAN devices, you have to create VLAN devices on these physical ports, and those VLAN devices can actually scale up to this number of VLANs, and you can see that every interface, number of VLANs, and that multiplies. And then bonds are nothing but the port channels, and these also are separate interfaces, network interfaces that group physical interfaces. Large number of interface attributes. Since we are a network switch, we have a bunch of network protocols running on our boxes. And each of these network interface protocols require a bunch of attributes to be specified on the interfaces. And as the number of interfaces increases, the number of attributes that you have to manage on all of these interfaces also multiplies. And network switches, mostly I've seen that it's static configuration, unlike your desktop environment where you want, for a desktop environment, you want to open your laptop and your network is connected. The same with the switch, but it's usually in a switch, you're not trying to connect to the best wireless connection possible and so on. So it's mostly static. You know you predetermined configuration, and your switch, when it boots up, it applies that static configuration to all the network interfaces. It doesn't dynamically do things unlike a desktop or a hypervisor where a VM comes and goes and you create interfaces on the fly. Challenges with existing Linux network interface managers on network switches. These are mostly found in the context of IF Up-Down and Debian and so on, but in general, we did evaluate a bunch of network interface managers, and here's a list of things that we found lacked that we wanted. Most of these are optimized for desktop and hypervisor environments, like I just indicated. Complexity increases with interface configuration scale. Now, when we are talking about 4,000 or 5,000 network interfaces, it suddenly becomes too complex to list these interfaces or to declare these interfaces in these other network interface configuration managers. And since network interfaces in Linux are usually stacked and they have an ordering dependency in them, burden of the network interface dependency is usually on the user. They have to declare their physical ports before their bridge, which is going to use them, or the VLAN devices which are going to be built on top of them. This might not be true with every network interface manager out there. There are new network interface managers coming up which have this capability, but we have found these limitations in the existing Debian interface manager. Lack of support for incremental changes. That's very key on a network switch. If you want to add a certain VLAN to a bridge, you don't want to bring the bridge down and do it. The network interface manager should be capable of just taking the incremental user configuration and apply it on the fly. And lack of tools to query and validate running interface configuration. So with that, a little background on IF Up-Down. Debian is a Linux distribution, as you all know, and Debian's default network interface manager until the VZ release that we were based on during our launch was IF Up-Down. Debian is also moving forward. Things are changing in that space as well with the latest releases. And a little bit about how network interface configuration is done in Debian. It's usually a file. It's EPC network interfaces, and every interface with its attribute you specify in an iFace section as in the slide. And the best thing about IF Up-Down is it allows pluggable it has a pluggable architecture. It allows add-on bash scripts. So on a production box, if you wanted to do something, if you wanted a script to be run after every network interface, you could actually drop in a bash script to do that, and the network manager would execute your script on every interface. That is a pretty cool thing. It's very useful. Now coming to the benefits and challenges. Pluggable architecture is very good, like I said. Use of Linux native tools, which Debian IFupdown does. Basically, it uses IP Route 2, BRCTL, and so on, which is really good. It helps faster development. You just install that tool on your system, and you can provide an IFupdown script to use that tool. It has good user documentation. It's a well-known tool. But the challenges, as I laid out in the previous slide, it's basically it doesn't understand dependency between interfaces. And when you're talking about 2,000, 3,000 interfaces, this becomes really complex. And large-scale configuration does result in two large files, and it's easy to debug. It's very difficult to debug and manage those files. No support for incremental configuration, no support to query and validate running interface configuration. So now introducing IFupdown 2. So because of those challenges that we had and because of the scale that we deploy Cumulus on, it became necessary that we had to solve some of the challenges for our users, and that's why IFupdown 2. And IFupdown 2 is basically, the first goal was because we already had people using IFupdown, customers using IFupdown, it was key to actually maintain the same backward compatibility with IFupdown. Basically, any tool that we build should be a drop-in replacement for IFupdown. So people had files, they should continue to work. That was the primary goal. And I chose Python mainly because in Python you have so many modules of existing network interface configuration modules that you can readily use, so it's faster development. And Python is very extensible. Continues to use existing native tools like IP Route 2, so that whatever fixes you do it in one place and you don't have to do it in multiple places. Attempts to meet all the shortcomings that we have seen with network interface managers on switches. And to continue with the pluggable architecture, IFupdown 2 actually takes Python modules. You can write a simple Python module. There are guidelines on how you can do that. And you drop in a Python module and IFupdown 2 will recognize it. This slide talks about architecture. It's a single package. A while back, it started with two packages. In the latest releases, we have merged into one for easier management. And so there are Python classes to parse, schedule, and order network interface configuration. And then there are these add-on modules. This is an LS output from one of our boxes, which shows that today we ship with these many add-on modules to configure network interface addresses, the bridge, ETH tool, and so on. And this is nothing but a picture representation of the previous slide. As you can see, the IFupdown 2 package actually calls underlying commands on Linux, such as mstpctl to configure mstp, brctl, IP Route 2, and so on. IP Route 2, I should mention that IP Route 2 is it is a Netlink-based tool, and all network interface configuration is moving in IP Route 2. So soon it will be the only tool to configure network interfaces on Linux. It contains many tools, many sub-tools like IP, bridge, and so on. ETH tool is a standard Linux tool, which if you remember from configuring speed, duplex, and gathering hardware stats on NIC ports on servers. So we have a IFupdown 2 module for that as well. And most of these modules, they spit out the native command lines to execute on particular network interfaces. This is a little more on the inside details. iFace object. The iFace section in the etc network interfaces file, it gets translated into a Python object called iFace object. And there is a config section in the circle on the right. You can see there is a dictionary of config attributes, which are taken from the user-specified interfaces file, and that is fed into every add-on module, like the bridge and address module. And these spit out the required native Linux commands to make that configuration, to translate that user configuration into the kernel parameters. So the next few slides talk about, dive into the details of how IFupDown 2 tries to solve the challenges that we talked about earlier. Network interface dependency. As you can see on the right, this is most typical stacked network device that you will see on our network switches. And you can see that you have to bring interfaces up in a certain order. You have to apply network configuration attributes like STP or IGMP or addresses on each of these devices, each of these blocks on the right in a particular order. So what IFupDown 2 does is it reads the interfaces file, gathers, makes a list of all the dependencies. It creates a dependency graph out of that, and does a topological sort on the network interfaces, and then calls all the modules that the user has supplied in a particular order to execute on every interface. So that's how the user doesn't have to care about listing the interfaces in a particular order. There is something called as built-in devices support. What we realized early on is we used to create the most created device on our system is a VLAN device in one particular configuration model. And that specifying those devices in the system, in the interfaces file, would take a lot of space, and it was unnecessary. So what built-in devices support does is it recognizes that a dot notation, for example, SWP1.100 is nothing but a Linux VLAN device on a switch port called SWP1. So the built-in devices support actually recognizes all these interfaces when they are specified as a dependency of another interface. For example, the most common use case is a bridge device with a bunch of VLAN devices. And so instead of specifying all the VLAN devices and the bridge devices in the file, you can skip the specifying the VLAN devices and only specify the bridge device, and it will pick up, it will understand that these are VLAN devices and it needs to create them in a certain order. And that did reduce a lot of, shrink the file by a magnitude. Incremental changes and query and validation. So IFupDown 2, let me go back to IFupDown a bit here. So IFupDown did not allow executing an IFUp on an existing up interface. And so if you had to have a bridge port added, a new bridge port added to a bridge, or a new VLAN, add a port to a new VLAN, you had to actually bring the bridge down and then bring it up with the new port. So that's clearly not okay on a production system, and so we had to develop incremental changes. So IFupDown 2 actually looks at the current running configuration against what is specified by the user and applies only the delta configuration. And ifquery is also an IFupDown command actually. But what I've done here is ifquery takes a new set of options to help the user debug or validate his config. For example, to the right, there is ifquery check BR0. What this does is ifquery check will tell you if the configuration on BR0, the running configuration on BR0 is same as what the user intended. And if it's not, the return value of this if case is non-zero, and it will execute an up, which will apply the delta. So this is a very useful feature. And next is IF Reload. So IF Reload was another helper tool added to reload the whole network interface configuration file by only bringing down those interfaces that had changed and bringing up the rest of the interfaces. This IF Reload has been enhanced in the latest version. It has an option to actually not do a down on any interface. It was initially added as a substitute to service networking restart, which would do a down of all interfaces and bring up all the interfaces. So we have variations of that in the new release. You can do an IF Reload to bring down interfaces that changed and bring up the rest, or you could do an IF Reload, only do an up on all the interfaces that are already up. Templating. Like I said, we have large files, and soon we realized that in a data center, most of these interface configurations are cookie cutter style. You want to create 100 bridges. They all look alike, except that they represent a different VLAN. So it was very easy to templatize, and there was a huge need to templatize, basically. And instead of building an inbuilt template engine and a syntax inside IF Updown 2, it was very easy for me to pick up something that was already there. There are many Python template modules that exist. And so what I did was I picked up Mako, which was used internally for other reasons, and it became a good candidate. But IF Updown 2 actually provides a pluggable template engine. So you can actually go to a config file and change your templating engine of whatever choice you want, and that will give you power to actually create your interface file or script your interface file in other ways. So for example, to the right you have this interface section with bridge, which represents a bridge, and there is a for loop which actually creates 100 bridges. And this used to take a lot of space in the files, or it used to result in too many files, which now becomes a small section, a for loop section. And the template engines, actually, they provide tools to render. So IFQuery itself can render this thing for you. For example, you feed this config file in interfaces file and run IFQuery. It's going to give you an expanded output. So IF Updown 2 can render it for you, but the template engines themselves come with special tools of their own. For example, Mako comes with Mako Renderer to be able to expand this file and see to yourself how if your config is right, and validate the config before you feed it into IF Updown 2. API, so the usual ask for any tool these days is JSON. So IF Updown 2 does support JSON. It takes input in JSON format. It's capable of outputting in JSON format, and this is considered very useful to integrate with automation tools, orchestration tools, and so on. And one more comment on the JSON slide. So most of the default commands of IF Updown 2, be it IF Up, IF Down, IF Query, they all take native format. They all take native format or interfaces file format, but every command has an option to input output in JSON. So you should look at IF Query help or IF Up help or the man pages to get a list of options. IF Query to persist running config. This was an experimental feature. I would say it's still an experimental feature because it does not cover all the config, but I have heard stories about this being very useful. It's basically, you can use the native tools like IP-link add to create interfaces, to assign it to a bridge, and so on. You have this whole setup, and now you want to dump all that config, running config on Linux into an etc network interfaces file format. And that is possible by doing an IF query running. And you can cat it to a file. And obviously, you will have to look at the file to see if the file generated is what you want, and then you can edit or add more to the file to make your complete interfaces file. But this has proven very useful to move from the old IF updown files to the new IF updown 2 format. So the past few days, past few months, we have been doing a lot of enhancements to IF updown 2, which actually I recently pushed to GitHub or GitHub repository. But this slide talks about some of these, like the new VLAN filtering bridge. The Linux kernel has 2 types of bridges. One is the classic bridge, I call it. It does not understand VLANs. It just forwards and learns. And you had to create separate VLAN devices for VLAN filtering and add to the bridge. But the new latest bridge driver in the Linux kernel, which is also available in the Cumulus kernel, is the VLAN filtering bridge. The bridge knows how to filter VLANs, and it allows you to configure VLANs directly on the bridge instead of creating this one extra layer of network interfaces. So we have full support for that in our latest release, and also in the GitHub repository with my latest push. LACP bypass for bond interfaces, MLAG. If you have seen, Cumulus recently released the multi-chassis link aggregation feature, and IF updown 2 allows, there is a module for that in IF updown 2, and it allows for easier configuration of MLAG. Then VXLAN interfaces, there is a section for that as well. There is a module for that. You'll find more details in the Cumulus user guide for the latest release, 2.5. There's a module for virtual router redundancy and IGMP and so on. And recently we have also, due to performance reasons, we have introduced direct kernel netlink API for some of the configuration. Because for basically these are strategically placed today. For example, if you're creating 2000 VLAN interfaces, using IP route 2 every time, forking IP route 2 every time can take a while. So in those places, we have hooked in direct netlink support to talk to the kernel directly to speed up a few paths. And to get started with IF updown 2, we have code on GitHub. There has been a lag from the first push to the recent push, but we, from now on, I think we'll be very diligent about pushing changes sooner, as and when they get into our internal repository. There is documentation on GitHub as well, but the latest documentation is always available from Cumulus releases. The GitHub repository is a little behind on documentation. And then there is a KB article. There are tons of KB articles, Cumulus articles on troubleshooting and trying to use IF updown 2 in a better way. I think I have a demo after this, but I think I'll take any questions.
And please remember, the lines are muted, so if you have any questions, please put them in the questions area of the chat window on your interface.
Okay, one question is IF updown 2 being used by other distros? Not right now. We will be pushing it to Debian soon. And we are hoping that today you can actually take it and install it on a server and use it as the way we do it on our switches. And there is documentation for that on the GitHub repository and also, I hope, on our user guide. Is it possible with IF updown to set up MLAG or synchronize some part of config between 2 switches? Today, the IF updown 2 support for MLAG is it supports the Cumulus distribution MLAG, which is very close to Linux native commands. For example, if you see some of the examples, It's nothing but an additional attribute on a bond interface. And yes, there is a whole infrastructure for MBLAG that comes with around it, which is needed to make it work. But IFFDown 2 can certainly configure that for you. Okay. Can you go back to the previous slide is one of the questions. Andrew. So Andrew, did you have any question on the previous slide? Okay, I will move to the next question. What changes were needed to boot scripts? None actually. There shouldn't be any. We did change the, yes. So the EPC networking init D script, which was part of IFFDown, that we enhanced that rather than remove anything from it. We enhanced it to support syslog and use the new options of IFFDown 2. Are you going to show a demo of the graph generator, or can you talk about it? Yes, I am going to show a small demo of the graph generator, and talking about it, I think I've covered most of it in my slides. So basically, every IFFDown 2 module gets to tell what its dependents are. For example, the bridge config is parsed by the bridge module, and it knows what ports it can parse. So that's how I get the dependency info. I will show it in a demo. Could you explain the operational difference between IF reload and IF up for an interface that is already up? For an interface that is already up, it is the same. So IF reload, okay, the difference between IF reload command and IF up is IF reload works on the entire interfaces file. It's like service networking restart. And IF up is capable of acting on all interfaces or an individual interface. So that is a big distinction between IF reload and IF up. So which means that IF reload always works in the context of the entire file. So if the user changed any specific section in the file, IF reload will down that interface and up that interface. But when you execute IF up on that particular interface, it's going to only apply the delta. So IF reload can be disruptive. That is, it can bring the interfaces down if there is a change. But in the recent releases, there was confusion about what IF reload can do, and so there is a newer option which will make sure that it will not down any interfaces. It will always act on up interfaces, and that particular option with IF reload makes it same as IF up on all interfaces. I hope that answers that question. You mentioned IF query features are in latest release. Do you mean latest IFFDown 2 or latest Cumulus 2.5? So the IF query features have always been there since the first release of IFFDown 2. And they are also available on GitHub. So you can actually download the sources from GitHub, build a deb package, and install it on any Linux, on any Debian Linux, and it should work. And yeah, so there is nothing so new in Cumulus 2.5 for IF query. It's always, the options have always existed. Do you have any actual config examples of these new commands being implemented? Yes, I do have examples. I will log into one of the boxes in just a minute. Will Cumulus be making a public deb package repo available at some point? So IFFDown 2 is a public package right now, public repo right now on GitHub, and there are instructions on how to build a deb. and most of our stuff is public. So yeah, I mean, it should be available. How ETH0 :1 is understand by the tools. So ETH0 :1 is a legacy. That's a legacy way, legacy Linux way to assign. Those are called as alias interfaces. That was a way. It was a way to assign multiple addresses on a single interface, multiple IP addresses on a single interface. But latest releases, latest Linux, I'm talking about plain Linux here, not Cumulus Linux. Latest Linux has moved away from it. You can configure multiple IP addresses on a single interface using IP ADDR command. That comes as part of IP route 2. So what IF Updown 2 does is, since the legacy IF Updown supported ETH0 :1, it translates ETH0 :1 address configuration on ETH0. So in one line, I guess IF Updown 2 understands it, but it just, since it was used to provide, configure multiple addresses on an interface, it just does that configuration for you. In your opinion, what would be the next set of enhancements to IF Updown 2? I guess the next set of enhancements, I would say maybe namespaces, VRF namespaces on those lines. But right now, we are more focused on getting this into Debian as soon as possible, getting most of these changes upstream and try to make it publicly available and push it more as far as we can. Please send your questions. Well, okay, sorry. And can you specify a device dependency on a protocol layer as opposed to a link layer? Tunnel over UDP waiting for IP to be available, whereas VLAN device only waits for link connectivity. Yeah, today we can only do at link NetDev layer. I'm not sure. Maybe there will be a way to. When you talk about tunnels over UDP and all that, it seems like, again, net devices, so it's probably possible, but today it only looks at links, link layer dependency. I'm just seeing, okay. When doing IFUP on a changed interface and applying the delta, what happens if the config is incorrect? It is going to throw an error. IFUP is going to throw an error. Can IFUpdown 2 run on a Dell S4810 as well as an S6000? Yes, absolutely. It can run on a server as well. Will IFUpdown 2 remove interfaces that are no longer listed in the interfaces file? Yes. Actually, ifreload will do it for you. Like I said, ifreload is a one command which runs on the entire interfaces file. So yes, ifreload will remove it for you. And you can actually do a service networking restart. So the service commands, nothing but they run the etc initd networking script, and that script nothing but internally calls IFUp, IFDown, if you see, in different ways. So if you do service networking restart, it's going to bring down all the interfaces, bring up all the interfaces. That is called IFUpdown, IFDown, and IFUp. And service networking reload will actually call iLoad. So this is very well documented on the Cumulus user guide page and also the GitHub page. Well, the we'll soon be updating the GitHub page as well, but all these things are documented. I think that is the end of the questions. I will just go to a short demo. Can you see my screen? Okay. I'm logging into a switch right now. This is CL Redstone XP, and going to cat etc network interfaces. So in this example, this is a simple example, but I will show a detailed example later on. We have a bunch of examples available on the box. So this is a network interfaces file which contains a loopback interface, an ETH0 interface, that's a management interface, then an uplink. The iFace uplink is nothing but a bond interface, which takes 2 ports. The bond slaves are nothing but 2 switch ports, SWP1 and SWP2. And the BR0 is a bridge. And the bridge ports line contains the ports of the bridge. So now you can, from this file, you can find the dependencies as well. For example, the uplink bond depends on the slaves, which are SWP1, SWP2. The bridge BR0 depends on bridge ports, which are uplink, SWP3, and SWP4. And the auto line in for each of these interfaces is nothing but telling IFUp-down2 to bring up these interfaces at boot up. The IFUp, the -A option that you've seen in all documentation is nothing but it says bring up all auto interfaces. This is carried over from IFUp-down. So IFQuery, okay, let me remember to clear the screen every time so it's clear. And IFQuery -A will show the contents of the file. Now, IFQuery -A always shows the rendered output. Even if you have used Mako or any of that thing in your Mako template or anything in your interfaces file, it will always expand the file. Now, IP link show up. So this is a Linux native command to see all the interfaces that are up. You can see ETH0 is the only interface that is up on the system. This is the management interface. Now what I'm going to do is I'm going to execute IFUp -A. And IFUp -A is usually silent, and that was done to just be backward compatible with IFUp-down, the Debian original IFUp-down. But there is an option -V, which will tell you every command that it runs. There is option -D as well, which is a debug, which gives you a ton of other information. So here, you can see there is a bridge interface, and there is an uplink interface, and all the other ports that are brought up. So you can actually do grep BR0 to see which ports are of part of the bridge. And it shows the bridge itself. When it says master BR0, it's nothing but SWP3 it's a slave of that master. In Linux, devices are stacked and they have a master-slave relationship. And so print dependency. So this is the first thing that IFUp-down2 builds when it reads the interfaces file. Whatever command you run, it's going to build this thing to get a view of what the user wants. So for example, LO, ETH0 don't have any dependencies. Then there is uplink, uplink is a bond here. It has SWP2 and SWP1, then BR0, and so on. So there is dot. You can create in dot format. You can dump this information in dot format. And this actually I had an example, and now I don't know where it went. Which can render your, 1 second. Let me share that. I don't know, did I lose my window to share?
I'm still seeing it.
You're still seeing it? Oh, sorry, I think I might have, I don't know what I've done here, but I have a picture of how it renders. So what you can really do is this dot format, printed dot format, you can actually cat it to a file and then display it on, you can create it into a PNG. And let me try to, oh yeah, I do have it. And can you see it? Yeah, so this is an example of the graph that I just printed out. So you can do if man IF query has enough details to actually show you how to do this. So here, for example, create an image PNG from the dot format. So this usually helps when you have tons of interfaces. But then with tons of interfaces, you can actually, your graph can look very complex and confuse you more, I guess. So, but here are some of the examples that are listed. With depends. With depends is another it's another useful option. What it allows you is if you're bringing only bridge 0 and what you've done is now you've done IF down BR0 and then you want to bring up only bridge, but now you don't know how you've messed up the dependencies. Maybe some ports have gone away in the process of bringing down the bridge. So what with depends does is it picks up all those dependencies for you that bridge 0 is dependent on and lists them for you. And I don't see this question window, so if you see any questions, could you let me know, Russ?
Yeah, I'm not seeing anything.
Okay, and what else? IF query minus H it has tons of options. For example, you can see there is native. For every format option, there is a native format and there is a JSON format. And minus X, I'm not sure if anybody has tried IFUp.2 and has used this option, but I find this option very useful. What it does is it allows you to exclude certain interfaces. For example, if I do an IF down minus A, it will bring down all the interfaces and you can lose your ETH0, but you can actually do this. And this will exclude ETH0 from your IFUp down operation. And yes, in the recent releases, we also have etc default networking, which gives you more flexibility or more logs during boot up. You can save that all IFUp.2 logs during boot up go to syslog and enable it in verbose mode and so on. And let me take you to some examples. User share doc. Python IFUp.2 is the package name. You can go to examples. We have examples mostly in every category. For example, SWP defaults. This one was actually generated. As you can see, this is a file generated by a script. And this script is also available here. What this does is it goes to an internal database of switch ports on a switch, and it actually can dump all of these interfaces in the interfaces file. And this, you can put this file in etc network interfaces.d. You can put a snippet of interfaces file in that directory, and you can source it from your main interfaces file. For example, you can copy CP SWP defaults into etc network interfaces.d, and you can source that from your interfaces file. For example, you can just say source etc network interfaces.d SWP defaults. This is another way to keep your interfaces file from not growing too large and too long. Basically, an easier management of your interfaces file snippets. This is an example of, the template function one is a complex template function, which you can maybe see later, but this is a simple example that I showed that was also in the slide. This is a Mako template. Now, you can use actually Mako renderer to print out the 1,000 bridges or 100 bridges this template offers. But you can take this exact for loop and put it in the interfaces file, and IF up down 2 will be able to render it for you.
We've got a question in the chat now.
Okay, what is the question? See, I can't seem to see. I don't know, I can't.
Okay.
Yeah, I can't see it.
Okay. The question is, a question regarding bridge dependency 1, when does BR0 get up after all the port links are running?
Yes,
And
that's
then,
correct.
and then 2, what happens to BR0 if one of the ports gets its link down?
One of the ports gets its link down.
That's what it says.
That is same way, it behaves the same way as it behaves on, without IF down 2. Basically, the port goes into, I guess there is no traffic forwarded to that port. Is that the question? I hope I've answered it. So if you want to remove a port from a bridge, you can, I'll show that example, I guess. ETC network interfaces. For example, if you want to remove a port from the bridge, for example, SWP4, and then you do IF up BR0. Sorry. Oh, sorry, I did an IF down in my last example. Let me bring up all the ports. Let me get back SWP4, IF up minus A minus X ETH0. Since I had left ETH0 up, for example, BRCTL show BR0 will show you it has SWP3, SWP4, and uplink. Now, I could go back and remove SWP4 and then do IF up BR0. And now I do BRCTL show BR0. It has taken out SWP4. And the same way, you can go and add back ports and do an IF up again, and it will bring up, apply the delta.
Next question, is there a way to configure a port name or a description?
Yes. Port name, no, not port name. Well, port name, uplink is a name here. So you could rename it to uplink 2. And you would make it uplink 2 here. And if you want to add a description, you can use, I think it's alias, because this is exactly same as how IP route 2 does it. Alias, say, webinar test. And since now I have removed an interface and I have put an interface, new interface, it's better to IF reload minus A. BRCTL show BR0. You can see uplink 2. And IP link show uplink 2, you'll see the alias printed here. Now IP link show is a native command. Now if I will run the same thing through IF query minus check, hope this works, check uplink 2. Yeah, see? What this command has done is it will go and look at the system. It will look at IP link show to check if the alias is applied and all these attributes on uplink 2 are applied. And you can see everything is a pass here, which means it has validated that everything is passed. Now I can also show you IF query running. IF query running is not looking at the interfaces file at all. It is just looking at the system. So what it did was it saw that uplink, it looked at the system, uplink 2 was a bond, and it picked that up, it picked up all the bond attributes, and it printed it into an interfaces file format. I am thinking a JSON will work here. I've forgotten the option. Format. Okay, format is the option. Format equal to JSON. Here, that's the JSON format. And going back to the examples, VLAN aware bridges. VLAN aware bridges is the latest in 2.5. Is there another question?
Oh yes, there is. Is there a way process to back up the configuration interfaces file, including contents inside source files?
Is there a way to back up?
Yeah. So the question is there a way or process to back up all the configuration in Etsy Network, including the contents of all the source files? So is there a way to have a unified backup of everything?
Unified backup, I would say you do an IF query -a, and this will give you a unified file of all the sourced files and all the templates and everything. It's all rendered at this point. As you can see, the SWP defaults also got in here. So IF query -a, and then I think you can just do root backup, interfaces backup. And yeah. Any other questions?
That's all the questions.
Okay. The last thing is this directory, VLAN aware bridges, has these new examples for the new bridge types. It has actually a MLAG example as well. So somebody had a question on chat a few minutes back on MLAG. So it's called CLAG internally, or well, maybe the external name is also CLAG. And you can see the MLAG ID or the CLAG ID is given in the interfaces file on every bond, and that's how it takes it. And VLAN, I'm talking about the VLAN filtering bridge. The VLAN filtering bridge is the new bridge that I was talking about, which understands VLANs. There is a lot of documentation on this, the classic bridge and the VLAN filtering bridge, and these examples are a very good start to start with any of these configurations. So, and the other thing is bridge ports. You can use regular expressions or globs in many of these. In the places where you provide dependencies, you can definitely use globs. Bridge ports is one thing, and then bonds is also another thing. And yeah, to really understand the new bridge configuration, there is an example file called the interfaces VLAN prune and access ports. That actually gives you details, all the details about how to configure this bridge, the new VLAN filtering bridge, and how you can give MSTP or STP attributes under the port. So previously, before 2.5 release, you would give all the bridge configuration under the bridge for all the ports that are part of the bridge. But in this new style of configuration, you can specify those attributes under the port, like the other network devices do, which was proved to be more intuitive. And those are the latest changes that we have done in 2.5.
Okay, great. Thanks, Rupa. We're out of time now, so I just want to take a moment to thank everyone for your participation. We hope that you found this presentation about IF Updown 2 useful. Please follow up with some feedback when we send you an email later asking how you like the session. The next scheduled webinar is March 25th, Open Hardware for All, Shrinking the Distance Between Customers and Great Open Networking Platforms with Andy Chen. You can also join us at Coffee with Cumulus each Thursday morning for a product overview and an introduction to Cumulus Linux. Details are available on the website at cumulusnetworks.com/webinar. Thank you for your time and have a good afternoon.
Thank you.